Hello, curious people. Forgive the unenthusiasm in my voice. I have not had a good day, and I just recorded a video and I recorded it the wrong way, so I'm redoing it. So, yeah, things are not going well. Anyways, today I will be explaining phase changes. So, you might be wondering, what is a phase change? Well, first, let's go over some terms and stuff. So basically, a phase change is just a physical change, and physical changes include melting, freezing, and evaporation, which is not all physical changes, but these three things will always be physical changes. So keep that in mind, it's very important. Anyways, in my last video, I talked about polar covalent bonds. Forget this, that shouldn't have been there. And polar covalent bonds is unequal sharing of electrons between two different atoms. So basically, this guy has more electrons than this guy because this guy is has more electronegativity than this guy does. So the electrons like him more. This makes him partially negative charge, partially negative charge. And this makes this guy partially positive charge because he doesn't have as many electrons as this guy does. Anyways, the example I used of this type of relationship happening in the last video was the example of water, H2O. So in H2O, you have an oxygen at the top and you have two hydrogens at the bottom, and they are polarly covalently bonded to each other. And so let's talk about this a bit more. So basically, these guys can connect because, remember, the oxygen has a partially negative charge, the hydrogens have a partially positive charge, and remember, positive and negative, they like each other, so these guys can bond. When these guys do bond, they form weak bonds known as hydrogen bonds. Okay, so let's pause there for a bit. So we know about hydrogen bonds and their weak bonds. They're weak bonds. But what does this have to do with water? Right. So remember, everything is always constantly moving. And when I say everything, I mean literally everything is always moving. Like nothing is still, ever. There's always something moving. Atoms, no, literally, atoms, they just always move. Everything's always moving. These guys are no exception. These guys are constantly moving, and because of that, these bonds, these hydrogen bonds, are constantly breaking between these polar molecules. So because they constantly break, they also constantly reassemble, and they constantly break and reassemble and break and reassemble, and this is what gives water its fluidity. So this is why water is so fluid. Now you might be wondering, what about ice and water vapor and stuff like that? Well, hold your horses. I'm getting there when I turn to the back. So, right. So you're probably wondering, what about phase changes? You know, the ice and all that stuff. Well, yeah, I'm about to get into that. Anyways, let me just clarify. This will now become this because I'm too lazy to draw this until I get to ice, because I kind of have to. So anyways, the guy from Khan Academy said this, and I thought it was a pretty helpful thing. We need to summarize what temperature is. Temperature is basically movement between atoms. When the atoms move faster, the temperature is usually high, and when the temperature is cooler, the atoms move slower. So basically, normally water is these hydrogen bonds that are constantly breaking and reassembling and breaking and reassembling. But what happens when you make these guys move quicker, aka raise the temperature? Well, when you raise the temperature, these bonds break and reassemble quicker and quicker and quicker and quicker and quicker, and they keep doing it to the point where they're barely even touching each other, and eventually they're just not. They're still there. These molecules are still there. The bonds are just completely gone. And this is basically when water evaporates. That might not be the best explanation of it, but it's how I was taught it in my biology class. So, yeah. we're gonna run with that. And basically, yeah, they're no longer able to form these hydrogen bonds, and that's what gives water vapor its airiness. So you might be wondering, okay, that's cool. What about ice? Well, like I said, the hydrogen bonds breaking, reassembling, breaking, reassembling. This gives you like normal water. But when you start to slow the movement, these bonds begin to form more, what's the word I'm looking for? I can't think of the word. They're forming better, basically. They're not breaking as much. And then eventually they form this neat ring-like structure. I couldn't draw it because I ran out of space and I'm very tired. So I just stopped halfway. But eventually, basically, the gist is it'll form a really neat ring-like structure that expands out pretty farly. And these hydrogen bonds are going to be fully formed. And this is what makes ice solid. But because these are basically expanded out, because, man, I wish I could show you the picture. Basically, the picture looks like this. This was ice. It's these really neat ring-like structures expanded out pretty far. And this is water, just really condensed. The hydrogen bonds are breaking and reforming and breaking and reforming. This makes ice less dense than water. And this is why ice can float inside of, no, that's a good, does it float inside of water or is it on water? Because it's not completely submerged, so it's not inside the water, but it's not directly on top. Actually, it might be directly on top. Anyways, that's why ice can float in, quotes, in water. Because it's less dense than water because of the way that it is structured, the way the bonds are structured. So this is why water does what it does. I hope this made sense to you. If it didn't, go watch a better video. And yeah, hope you have a great rest of your day and stay safe.